Good morning, dear children. Last class we have done displacement reaction. So in displacement reaction, what we do, we'll do a very quick revision. In displacement reaction, more active metal or non-metal replaces or displaces less reactive metal or non-metal from its compound. So more active will be displacing less active. So in displacement reaction, more active element displaces less active elements. Now here it is double displacement reaction. That means here one will be displacing, more active will be displacing less active, and then less active will take place of the more active. So what they do is they just exchange their ions. So they just exchange their ions. A chemical reaction in which two compounds in their aqueous state means when they are in their solution form. That means if AB is the compound, then this AB has to be dissolved in water, and CD also has to be dissolved in water, and then finally when you mix this AB and CD, then there will be exchange of ions. That means their part will get exchanged. So their ions or radicals to form new compounds is called a double decomposition reaction or a double displacement reaction. For example, AB plus CD gives CB plus AD. Now what you can see here is AB is a compound. A is basic part, B is acidic part. CD is a compound. C is basic part, D is acid part. Or you can say A is positive part, B is negative part, C is positive part, D is negative part. Now positive part will be displacing positive part only, and negative part will be displacing negative part only. So here what is happening, in place of A, what is coming? C, which is a positive part itself, mind you. A compound, like for example, if you write AB plus CD gives AC plus BD, then that is not the reaction. Why? Because in that case, if you write AC plus BD, then a compound can be formed by both positive parts. A compound always should have positive part as well as negative part. Positive part, metals are positive part, bases are positive part, non-metals are acidic part, negative part, and acid radicals are also negative part. So a compound always should have positive part as well as negative part. So what is happening here, in place of A, C is coming, so it is forming a compound CB. That means positive part is taken by positive part, and in place of C, A is going. In place of C, A is going. In place of A, C is coming, and in place of C, A is going. That means there is exchange of ions. There is exchange of ions. If it is element, if it is group of atoms, then exchange of radicals. If there is a single atom, then exchange of ions takes place. If there is group of atoms, then exchange of radicals takes place, and this reaction is called double decomposition reaction as well as double displacement reaction. Now double displacement reaction are of two types. They are precipitation reaction and neutralization reaction. So what is precipitation reaction we'll come to know, and what is neutralization reaction also will come to know. Now precipitation reaction, a chemical reaction in which two compounds in their aqueous state react to form an insoluble solid or precipitate, as one of the products is known as a precipitation reaction. So precipitation reaction is also double displacement reaction or double decomposition reaction. Okay, but what happens here is when you are combining this combining the solution of two compounds, when you are mixing solution of two compounds, then one of the product will be insoluble solid, one of the product will be insoluble solid. Now you can see here what is happening is you are adding two compounds AB and CD. AB is one compound and CD is another compound. AB is combining with CD and we are getting two products, two reactants, two products. Mind you, in combination reaction, any number of reactants but product was only one. In decomposition reaction, reactant was one, product can be of any number. Then in displacement reaction, again, two reactant and two product, but in displacement reaction one of the reactant has to be an element, in the reactant side, and in the product side also one of the reactant has to be one of the product has to be an element only. But here in double displacement reaction, both the reactants are compounds and both the products are compounds because exchange of ions takes place here. So I was saying you this precipitation reaction is also this double displacement reaction in which two compounds in their aqueous state, means in their solution form. I was saying like conditions for reaction. Number one was close contact and number two is solution form. So this this double displacement reaction, for a condition required for this double displacement reaction is the reactant has to be in solution form. Otherwise the reaction does not take place. So in this reaction, in particular in precipitation reaction, what happens, one of the product is insoluble solid, and this insoluble solid which is formed as a result of precipitation reaction is called a precipitate. Okay, so let's see what is precipitate in detail. A precipitate is an insoluble solid formed when two compounds in their aqueous solution state react chemically with each other. So what is a precipitate? It is an insoluble solid formed when two compounds in their aqueous solution state reacts chemically with each other, and the product formed is insoluble solid. This insoluble solid formed as a result of precipitation reaction is called a precipitate. So in short, what you can say, a precipitate is an insoluble solid formed as a result of precipitation reaction. It is indicated by an arrow pointing downwards in a chemical equation. While teaching you chemical equation itself, I have said you how is precipitate represented in a chemical equation. In a chemical equation, it is indicated or represented by an arrow pointing downward. So what is indicated by an arrow pointing upward? Yes, it is a gas. Okay, then let's see examples. When barium chloride solution reacts with sodium sulfate solution. So barium chloride solution, I am saying solution of a compound barium chloride and solution of a compound sodium sulfate. When these two are mixed, you can see here two test tubes are given, two test tubes are there. One test tube is having sodium sulfate solution. So how will you make this solution? First of all, in this test tube you will be adding sodium sulfate solid, and then you will put water, and then you will mix it nicely, then you will get a solution. So make sure that none of the residue is left at the bottom. So that means the solution has to be clear, none of the solid should settle at the bottom. So that much you have to mix it, that much you have to stir. So if you are finished with making solution of sodium sulfate, then take another test tube and put some barium chloride solid in it. Then again put water and then again stir it, dissolve it. Then when both of the test tubes are with clear solution of sodium sulfate and barium chloride, then what you can do is hold this sodium sulfate solution in one hand and barium chloride solution test tube on the other hand, and put it slowly on sodium sulfate solution. Put this barium chloride solution in sodium sulfate solution. Then what you can see is at the bottom you can see white precipitate. So initially both the solutions were very much clear, nothing was at the bottom, but when you mix these two, okay, so why I said you have to dissolve it thoroughly, so that you may not get confused that okay, initially there was solid at the bottom. Okay, for that only you need to dissolve it very nicely, dissolve it very nicely. Then when you get clear solution of both the compounds, then you can mix it slowly. So when you are mixing, you can see a white solid is formed at the bottom of sodium sulfate, at the bottom of the test tube containing sodium sulfate solution. So when you'll empty this barium chloride solution, then you can see a white precipitate of barium sulfate. So previously it was barium chloride. Now what is formed at the bottom of the test tube containing sodium sulfate solution? It is barium sulfate. That means barium has taken sulfate radical. Barium has taken sulfate radical. Then sodium will be taking chloride ion. Sodium will be taking chloride ion. So you can see the reaction here. Barium chloride combines with sodium sulfate. This AQ means solution in water. Then what you are getting? Barium sulfate, white precipitate, represented by downward arrow, plus sodium chloride. Now can you see? Chloride was with barium. Chloride was with barium, and this side in the product side you can see barium is with sulfate, not chloride. Barium is with sulfate. That means they exchange. Barium is taking sulfate and sodium is taking chlorine. Barium in place of barium, sodium is coming. In place of sodium, barium is going. So there is exchange of ions. There is exchange of ions. In this way, precipitation reaction takes place. In this way, double displacement reaction takes place. Then you can see some more examples of a precipitation reaction. Silver nitrate. Silver nitrate. AQ means silver nitrate solution plus hydrochloric acid. It is already liquid, so no need to make solution out of it. So silver nitrate plus hydrochloric acid, when you react, when you combine, then you will be getting silver chloride as a white precipitate and nitric acid. So one of the product, what is the condition for a precipitation reaction, what is very much specific for a precipitation reaction? One of the product must be insoluble solid. One of the product must be a precipitate. One of the product must be a precipitate. So in number 2 also, copper sulfate reacts with sodium hydroxide to give copper hydroxide, which is a blue precipitate, and sodium sulfate. So both cannot be insoluble solid, only one can be insoluble solid, so that we can identify. So in this way, double displacement reaction, that means precipitation reaction, takes place. So this is double displacement reaction as well as precipitation reaction. All precipitation reactions are double displacement reactions. So here, what is the criteria? How to know that a precipitation reaction is taking place? By seeing a precipitate. If the precipitate is forming, you can say it is a precipitation reaction. Then Neutralization reaction, I was saying you double decomposition reactions are of two types. One is precipitation reaction, in which one of the product is precipitate, insoluble solid. But this is different, totally different. Neutralization reaction. Now you know the meaning of neutral. Neutral means -1 + 1 0, neutral. -2 + 2 neutral. -3 + 3 neutral. That means if there is equal number of minus and equal number of plus, you will be getting neutral. Again, why an atom is neutral? An atom is neutral. Why? Because there are equal number of positively charged proton and negatively charged electron. So atom is neutral. So this is neutralization reaction. Now, when you are suffering from acidity, there is a lot of pain in your stomach because of acid formation. So when there is acidity, what you will do? Doctor will prescribe you to take Dizin or Gelusil or Disozyl, anything which is a base, Then when you will take this base combines with the acid present in your stomach and neutralize acid. This base neutralizes acid. And forms salt and water. So that is the reason why this reaction is called neutralization reaction. So let's see the definition for neutralization reaction. A chemical reaction in which a base or an alkali reacts with an acid to produce a salt and water only is known as a neutralization reaction. So in a precipitation reaction, one of the product was a precipitate. But in neutralization reaction, two reactants, one is acid and one is base. And the products are always salt and water. So acid plus base reacts to give salt and water, and this is neutralization reaction. Acid will be neutralizing the effect of base and base will be neutralizing effect of acid, nullifying. Acid will be nullifying the effect of base and base will be nullifying the effect of acid. Okay, so it becomes neutralization reaction. You can see here red litmus changed into blue in an alkaline solution. So if there is alkaline solution, for example, if you dissolve sodium hydroxide in water and put red litmus paper, okay, red litmus paper in it, then you can see this red litmus paper turns to blue. And in other case, if you see blue litmus changed into red in an acidic solution. But in an acidic solution, if you put a blue litmus paper, then this blue litmus paper will turn to red. So what is the specific property of an alkali? Alkali can turn red litmus to blue. And what is the specific property of acid? Acids can turn blue litmus to red. So let's see example when an alkali, sodium hydroxide. So sodium hydroxide is a very strong alkali. Why it is called alkali? Because this is water soluble base. All water soluble bases are alkali. But all bases are not alkali. Why? Because all bases are not soluble in water. Only those bases which are soluble in water are alkali. Sodium hydroxide is alkali because it is soluble in water. Reacts with hydrochloric acid. It forms a salt, sodium chloride and water. You can see sodium hydroxide is a base, reacts with hydrochloric acid is acid to give sodium chloride is a salt and water. Now how to know it is a salt? Salt always have both the part, acid radical as well as basic radical. In base, how to know it is a base? If it is ending with OH, a compound ending with OH, a compound ending with OH is a base. A compound beginning with H is acid. Compound beginning with H is acid. Okay, so compound ending with OH is a base, and compound starting with H is an acid except water. So salt will have basic part as well as acidic part. Sodium is a basic part and Cl is acidic part. Then it forms a salt. Then water is formed. Water is also neutral and salt is also neutral. Then another example, if you see, then zinc oxide, which is a base, reacts with nitric acid to form a salt, zinc nitrate and water. A salt, zinc nitrate and water. So zinc oxide plus nitric acid gives zinc nitrate plus water. You can see here the displacement is taking. See, zinc is coming in place of hydrogen. Zinc is coming in place of hydrogen, and hydrogen is going in place of zinc. Zinc is coming in place of hydrogen and forming zinc nitrate. Hydrogen is going in place of zinc and forming water. So double displacement, exchange of ions are taking place. In case of A also, sodium is going to the place of hydrogen and forming sodium chloride. Hydrogen is coming in place of sodium and forming water. In this way, exchange of ions takes place. In this way, these are the double displacement reaction. So double displacement reactions are of two types. They are precipitation reaction and neutralization reaction. So in precipitation reaction, any two compound in solution form can combine to form an insoluble solid as one of the product. Then that is a precipitation reaction. But in a neutralization reaction, acid combines with base. No two compounds, but acid combines with base to give salt and water. Then some more examples of neutralization reactions are sodium, potassium hydroxide, sulfuric acid reacts to give potassium sulfate and water. Then you can see here potassium is taking place of hydrogen and forming potassium sulfate, and hydrogen is coming in place of potassium and forming water. Then copper oxide reacts with nitric acid to form copper nitrate and water. All metallic oxides and metallic hydroxides are called bases. So all metallic oxides and metallic hydroxides are bases, but only those bases which dissolve in water are called alkalis. Acids are those substances which when dissolved in water produces hydrogen ion as the only positive ion in their solution. That means acids are those substances which when dissolved in water produces hydrogen ion. Then activity number 5, to show a neutralization reaction. Now you can see here dilute sodium hydroxide plus phenolphthalein solution is pink. Dilute sodium hydroxide, that means which is a base. So base when comes in contact with phenolphthalein, that means in a base if you put phenolphthalein, then if you put phenolphthalein in sodium hydroxide, it turns to pink color. Now if you add dilute hydrochloric acid with the dropper slowly, then you can see that this pink color will go on fading. Then finally this pink color will become colorless. So from this what we can understand? The effect of sodium hydroxide, because of the effect of sodium hydroxide, this solution was turning into pink when coming in contact with phenolphthalein. Okay, sodium, because of the effect of sodium hydroxide. But now slowly, so this hydrochloric acid is added, that means the effect of sodium hydroxide is reduced slowly. As a result, the effect of sodium hydroxide is reducing and the color will go on fading, and finally it turns to colorless. Finally it will become colorless. Again, if you add some sodium hydroxide, it will turn. Again, if you add a few drop with the help of dropper, if you put sodium hydroxide, again it will start becoming pink. And again, if you put acid slowly, then again it will become colorless. That means uh, acid can nullify, can neutralize the effect of base, and base can neutralize the effect of acid. So this is all about double displacement reaction. Thank you.